Hello everyone. So in this class, let's see some SAQs from gravitation chapter. So first SAQ, let's discuss. What is geostationary satellite? State its uses. This question they will ask you for 4 marks in IPE exam. This is short answer type question. What is the question? What is geostationary satellite? State its uses. So first of all, what you have to do, you have to define geostationary satellite. You have to mention its time period, and then you have to write some uses. Okay, let's see. Now, definition. If a period of revolution of an artificial satellite is equal to the period of rotation of Earth, then such a satellite is called geostationary satellite. For example, this is suppose Earth, you can see here, and suppose this is a satellite. Now, the period of revolution of this satellite, if it is equal to the period of revolution of Earth or period of rotation of Earth, then we can say that it is a geostationary satellite. So Earth completes one rotation in 24 hours. So if this geostationary satellite completes it in 24 hours, then we can say that that is also a geostationary satellite, or that is just a geostationary satellite. Understood? So the time period of geostationary satellite is how many hours? 24 hours. Okay. Next one. Now its uses. First of all, what is use of this geostationary satellite? We can study upper layers of atmosphere by using geostationary satellite. Next one, to forecast the changes in atmosphere, like weather forecasting and all. This is second use. Next, to know the size and shape of the Earth. So how is the shape of Earth? How is its size? All these things also we can study by the use of this geostationary satellite. Next one, to identify the minerals and natural resources present inside and on the surface of the Earth. So here are the minerals present, yes, natural resources and all, everything we can study by using this geostationary satellite. So you have to write definition, you have to mention about time period, and these 4 uses you have to write. Okay, in the exam. Understood? Note down. So let's see next answer. State Kepler's laws of planetary motion. This is another question. This question also they may ask you for 4 marks. How to write the answer of this question? You have to write the Kepler's laws of planetary motion. How many laws are there? You know. How many are there? 3 are there. Okay. So let's see one by one. Now, first law, that is called law of orbits. And what it says, all planets move in elliptical orbits with the sun situated at one of the foci. Means what? Assume that this is a ellipse or one elliptical orbit we can say. So if sun is situated here, these are the 2 foci. So out of that, at one point I am assuming that sun is here, and this is what the planet is, which is revolving in an elliptical orbit, considering sun at one of its foci. Understood? This is what your first law. That is called law of orbits. One more time, listen. All planets revolve in or move in elliptical orbit with the sun situated at one of the foci. Okay. Now let's move ahead. Next law, that is law of areas. What is that? Law of areas. What it is saying, the line that joins any planet to the sun sweeps equal areas in equal intervals of time. Let me explain. As usual, this is what elliptical orbit can say. Here, I'm assuming that this is sun situated here, and this is what the planet is. Now, this is what the line joining sun and planet. Now, this planet comes here. This is one position. Again, somewhere here also. And this is what we can say, some lines which I have drawn. Now you see the planet came from P to P dash and from P dash to P double dash. Now let us suppose this area, it has swept in time, let us suppose T second. And this P dash, yes, P double dash, this is also in T second. If the time is same, then we can say that these two areas are also same. Also same. These two areas also same. Understand? Means the planet sweeps out equal areas in equal intervals of time. Got it? Particularly the line joining sun and planet. Yes, this is what? Law of areas. The line that joins any planet to the sun sweeps out equal areas in equal intervals of time. This is your second law. Okay. Now, third law is called law of periods. What it says, the square of the time period of revolution, the square of the time period of revolution of a planet is proportional to the cube of the semi-major axis of the ellipse traced out by the planet. That is, t square is proportional to a cube. Now let me explain. This is a ellipse. As usual, here sun is there, here planet is there. Okay. Now let us suppose the time taken for one revolution is, let us suppose, t. And you know, this is the major axis, this is minor axis. And this one is semi-major axis, that is A, from this point to this point. Semi-major axis. Or we can say this semi-major axis is nothing but average distance between sun and planet. So, according to this law, if time t is taken by the planet for one revolution, then square of this time period of revolution is directly proportional to cube of semi-major axis. This is what? Law of orbits. Okay, understood? Note down.